The next form of renewable energy that we're going to look at is pump storage hydroelectric systems. Before we get into the pump storage side of things, let's look at what a hydroelectric power station actually does. And it's all about water and the movement of water, and they convert the gravitational potential energy, gravitational potential energy is converted to kinetic energy, and that's basically, first of all, by allowing the water to flow, say, over a weir or out of a dam. So gravitational potential energy of water to kinetic energy, and then that's transferred to a turbine. And again, that turbine turns a generator, and the generator generates electricity. So that's the way that hydroelectric systems in general work. And let's finish that off. So there's what the hydroelectric systems do themselves. I want to just quickly refer back to the other types of power that we've seen so far, and whether it's wind or fossil fuels or nuclear power. Those other power stations are known as baseload stations. And a baseload station basically produce energy, not so much on demand, it's more just producing it continually. And so there's a little bit of a feasibility issue, in that if we're continually producing energy, we might not actually always need all of that much energy that's being produced. So we want to be able to not just sort of have it go to waste and not be used. We want to make sure that we can use it in an effective way. And so the issue there is that demand is sometimes going to be much less than the supply. So the excess, we want to be able to store that. So if we have that, the demand being nowhere near what the supply is, the excess can be wasted. With pump storage, we can actually make use of that wasted energy. So with pump storage systems, the excess energy will be used, or can be stored, I suppose. Stored by pumping water back up into a reservoir. So instead of letting that excess energy escape or be wasted, we take some of that water that's been used in a hydroelectric plant, and we store it or pump it back up into the reservoir, and that means that water can then be released at a later stage, and we can then use that stored gravitational potential energy. Now the way that it's pumped up to higher reservoir again is where the turbine operates in reverse. So usually the turbine is where water will run over the turbine and cause it to turn. With pump storage, we actually sort of operate in reverse, put energy back into the system, pump the water back up to the top. So there are some waste forms there again, but ultimately we're reusing some of that energy to store water in a reservoir so that it can again be run back over the turbine. And the gravitational potential converted back to kinetic. So it doesn't store all of the excess energy, but certainly doesn't allow all of the excess energy to be lost in waste heat forms. To have a look at a diagram here, so just to make a bit more sense of those ideas, with a hydroelectric plant, we'd have water in this scenario being allowed to run down through this pipe here, out past the turbine and into the discharge area. So that's how the hydroelectric plant would usually work. With the pump storage, we'd make sure that this water can't necessarily escape, or it's sort of stored in a lower reservoir, so that in times where there is excess energy, this turbine in here operates in reverse. Water is then pumped back up into the reservoir, and then we can, like I say, reuse it again at some later stage when we need to produce energy. In some cases, the reservoir that we have up the top here, it might actually be separate to the usual source for the hydroelectric plant. So you can sort of have that water being stored off to the side and then diverted back through the turbine as needed. So it'll sort of depend on the situation. Now, in terms of some of the questions that you might see on past exam papers here, there aren't actually any equations in the data booklet that relate specifically to pump storage. However, there are some relevant equations that you should be able to incorporate or consider when you're looking at the idea of pump storage. So the first one is the density of water, so mass over volume. So that can be used if you're sort of looking at, in particular, if you're looking more at flow rates. So if you had something like a flow rate in cubic meters per minute, that would then allow you to, if you use the density of the water, you know how much volume there is per minute, you could then figure out exactly what mass of water would be used as it flows through as it flows through a turbine. The other one that's important to remember here as well, or two, change in potential energy is equal to mg delta H. So looking at how much potential energy is stored in the water, how much is then converted to kinetic energy. So again, good old kinetic energy being half mv squared. So if you know, if you've got the flow rate again, cubic meters per minute, you might then be able to use the volume to figure out what the flow rate is in terms of the speed of the water, which could allow you to calculate the kinetic energy. So a couple of different ways that you can consider the energy there. And then finally, power being equal to energy over time, or work over time. So work and energy being equivalent. So you could use those as equations that you might need to use in order to answer some of the questions on past exam papers. In the next video, we'll have a look at the last type of renewable source that we need to be aware of, and that's solar energy.